Today we are discussing energy storage technologies in smart grids. We will be covering energy storage technology, the types of energy storage, benefits of energy storage, and the disadvantages of energy storage.
Electricity hasn't always been the easiest source of energy to store. It is only in the recent years with technical advances that we've been able to store it in the vast amounts that we do nowadays. We have finally caught up to which it is demanded thanks to the smart grid. Thanks to our new and constantly improving transmission lines, we can keep up to the high demand of electricity needed and make sure to feed it to the grid accordingly.
Now we're going to talk about types of energy storage in the smart grid system. Batteries, more specifically electric batteries, store electric energy and is discharged when a storm happens, thus power outages, and instead of having outages, we have a battery backup system that almost seamlessly switches the energy back on so people don't have to worry about blackouts. Flywheels are just like batteries, however they are rotors placed within a vacuum, and it stores the energy which is discharged through kinetic energy like a motor. Compressed air uses off-peak energy to pump air into a containment area such as an underground mine. This is then released through a combustion turbine, and it is used sometimes with electric or natural gas fuel, which increases in efficiency. Vacuum air storage systems are basically the opposite of compressed air, where instead of in off-peak energy is used to create a vacuum which is repressurized, creating an airflow when power generation is needed. Electric vehicles are pretty cool because you can use the battery in an electric vehicle to put it into the smart grid, or you can use the smart grid to dump into the car as a load instead. So, like I said, batteries are not always electrical energy. Thermal energy can also be stored. So during off-peak hours, energy can be stored as thermal energy. You can also use solar thermal systems, and they are being used more around the world to supplement or replace the electrical energy drawn from the grid. Inversely, ice can also be used to cool buildings, which also allows less energy consumption. Fuel production also uses fuels to generate the electricity. Little bits of electricity, like an internal combustion engine, might be needed to get explosions happening, but it's greatly decreased because we're using other alternative uses to create the electrical energy. Magnetic fields are capable of storing electrical energy, and when coupled with superconductors, the storage potential can be very significant. However, the cost of the superconductors might be so high that we might not be able to use them as efficiently as other uses. Last but not least, pumped storage uses hydroelectric power, which during lower price periods pumps water into a reservoir like a tank, and then this water, using gravity, can turn a turbine, almost like basically Niagara Falls is one of these power generators, using the kinetic energy from the falls to create turbines, which in turn turns it into electrical energy and dumps it into the grid.
There are many benefits of energy storage using a smart grid system. Transmission and distribution equipment will require less upgrades and replacements, as using a smart grid system is very productive and will not require much upgrading. The electronic batteries used in the smart grid can self-dispatch to local loads when needed. This comes in handy during emergency situations such as hurricanes, tornadoes, or other storms where power outages are present. These batteries can dispatch power for up to 8 or more hours without concerns such as fuel availability, emissions, and noise. With the types of energy storage the smart grid can offer, we can control voltages easily, provide power factor correction within the system, and minimize on-load tap changes. Power flow management is much more improved using this technology. We now have the ability to redirect power flows, delay network reinforcement, and reduce reverse power flows. Having all this available stored energy provides us with power to assist island networks and support black starts. Using a smart grid creates many benefits with the different types of energy storage systems used.
Now we're looking at the cons, or the bad side, of the smart grid energy storage. You've got three main causes of negative impact from this. You've got the cost, the privacy, and the health risks. Some places might be able to save on the costs because of you turning off, in residential areas, turning off a stove or heat, or turning the heat lower. But other places like daycare facilities or hospitals, they can't turn the power off, which causes the cost to just rack up. And this is a negative thing because the government has to pay for it, and thus the taxpayers have to pay for it. Another concern is privacy. With the smart grid system, you've got Wi-Fi signals, you've got cellular technology, and through these things you can get hackers and people trying to steal your identity. And even the government, we've heard all these rumors about the US government keeping a watchful eye on everyone. If you're on the internet, everyone is watching you. People are watching you, and not very many people like that idea. Thirdly and lastly, health risks. There have been studies that the people within 1,500 feet of a cell tower are reportedly higher cancer rates. People with fertility problems, or even memory loss, sleeplessness, and skin rashes. These things have been, in studies, shown that people have these things, and now that the smart meters are being installed in their homes, this can also be a problem because it'll be localized, not just to 1,500 feet away from a cell tower.
Overall, after looking at the many uses and applications of the smart grid technologies, we see how vastly it has changed our lives and will continue to change our lives as the industry grows and adapts to modern times. From renewable energy sources to energy efficient resources, it's helping us create power to keep up with the current growing demand for electricity with less effects on our environment. Using it and its energy storing capabilities, we can now store larger amounts of electricity than ever before, changing the way we dispatch it to the grid via the transmission lines. By using new smart metering techniques, we are eliminating the need to have workers constantly checking and monitoring the electrical grid for flaws, errors, and theft, saving money for the producers of the electricity, which is then passed down to the consumers. When looking at both the pros and cons of the new technology, we can clearly see that the pros definitely outweigh the cons, showing that there's potential growth in the smart grid energy storage sector.